Greetings, math fans. All right, so this is day two of Calculus 3A, Chapter 3A. Again, we're going to be talking more about the derivative. Remember, the derivative is the slope of the tangent line, or the slope of a curve at a certain point. Okay, and remember, that's what you have f prime or f of x and f prime. So this is your original function, and the f prime, or the derivative of f of x, is your slope of a tangent line. And guys, just to refresh your brain, if you have a curve like this, and I'm trying to find the derivative at this point here, what's going on is you might have a secant line and another secant line and another secant line until you actually get to the tangent line, and then it's actually the slope at that point. Okay, so we're going to be talking about secant lines and tangent lines. All right, so let's kind of keep that in mind. All right. Number one, it says, at what point is the slope of the tangent equal to negative 1/3? Well, you set f prime of x equal to negative 1/3. It's basically what you have here, right? I'm telling you what the slope is. That's f prime is the slope, so we have negative 3 over x minus 1 squared equals negative 1/3. Okay, and a little cross multiplying here, so we get x minus 1 squared. Negative equals negative 9. Of course, the negatives cancel to positive. So what you have is x minus 1 squared equals 9. So I can take the square root of both sides. And I get x minus 1 equals plus or minus 3, right? Square root of 9, 3. So we got two problems here. We got x minus 1 equals 3 and x minus 1 equals negative 3. So x equals 4 and x equals negative 2. And notice, math fans, what I pointed out the other day, what points. So I'm looking for a coordinate here. Okay, and how do you know which function you plug it into? You plug it back into the original function. Okay, you got to know that. So really, I have f of 4 is equal to 3 over 4 minus 1, or 3 over 3, which is 1. So my first coordinate is 4, 1. That's pretty easy. And then f of negative 2 is 3 over negative 2 minus 1, or 3 over negative 3, which is negative 1. So my coordinate is negative 2, negative 1. So please be careful if I ask you for a coordinate, give it to me. Okay, so those are our two answers. Okay, next part. Find the slope of the secant line. The secant line contained by the points at x equals 4 and x equals 6. So this is the deal. I don't know what this curve looks like, but I'm just going to, if I made a quick sketch here, and I gave you 2 points, one here and one here, and I asked you, because I gave you 2 points, and I asked you the secant line, I'm asking you for the slope of that line. What do you do to find the slope? If I told you x is 4 and x is 6, how do you find the slope of the line? Well, isn't it just the yax? Oh, good old yax. See, using the yax right in that corner right there, watching you. Anyway, it's you plug in the 4 and 6, but of course I need a coordinate, don't I? So it's truly what the yax is y over x. So the same thing, y is the same thing as f of x. You guys agree with that? So isn't it saying f of 6 minus f of 4 y over x? Isn't that what that is? So you got to know that. That's the slope of the secant line, is you actually do the yax. The slope of a tangent line, you got to use the derivative. The slope of a secant line, you use the yax. That's what it is. Okay, so remember I'm plugging that into the original function, 3 over x minus 1. So if we do that, we get 3 over 6 minus 1, or 5, minus, I plug a 4 into there, so 3 over 3, right? 4 minus 1, all over 2. So again, you plug this in your nice little graphing calculator, and it's really 3/5 minus 1, negative 2/5 over 2, and our answer comes out to be negative 1/5. Pretty easy. Find the slope of the tangent. Ah, the tangent line. So what are you going to do? Plug it in the first derivative. F prime of 6. Really easy. So we get negative 3 over, and making sure you plug it into that second equation, right? So it's going to be 6 minus 1 squared. So negative 3 over 5 squared, or negative 3 over 25. Okay, that's the slope. Okay, keep going here. Write the equation. Very interesting. Write the equation of the tangent line for f of x at x equals 8. Okay, so that just means I need to find the slope, right? So let's do that. If I find the slope, isn't it f prime of 8 is equal to negative 3 over 8 minus 1 squared, or 7 squared, which is negative 3 over 49. So remember, this is your slope, math fans. And what you want to do is you want to write this in point slope form. Whenever I ask you to write an equation, always use point slope. You would be foolish, and I've talked about this before, you'd be foolish to write in any other form but point slope form, because you have to do more work in other forms, and it's a good possibility you can make a mistake. So what I need to do is I need to find out a point. Well, x is equal to 8, so I find out what the y value is. Oops, f of 8. And I plug that into that. I get 3 over 8 minus 1, which is 3/7. So my coordinate is 8 comma 3/7. Okay, so my equation is y minus y1, or y minus 3/7, equals the slope, which we figured out right here, negative 3 over 49, times x minus the x minus 8, right? That's it. That's your answer. Not that difficult. All right, let's do number 5 here. Write the equation of the normal line. So this is, what is a normal line? If you guys remember, it's perpendicular, which means the slope is the opposite reciprocal. So the first thing I need to do is I need to find f prime of 7. So f prime of 7, that's the slope of the tangent line. That is negative 3 over 7 minus 1, or 6 squared. So negative 3 over 36, which is negative 1/12. Okay, that's the tangent line, so my normal slope is going to be positive 12. Okay? And again, I have my x equals 7, so I need to find f of 7 to find my y value. And that's just going to be 3 over 7 minus 1, or 3 over 6, which is 1/2. So my coordinate is 7 comma 1/2. So my equation is y minus 1/2 equals 12 times x minus 7. Okay? That's pretty much the lesson, math fans. That's actually a very quick lesson. Just it's making sure you understand the difference between slope and slope of a secant line and slope of a tangent line. Yacht for secant, derivative for tangent. All right? That's it, math fans. Adios. Goodbye.